Hello and good afternoon, everyone. My name is Brandon Carter. I'm an application engineer with Ally PLM Solutions. I want to welcome all of you to the Ally PLM NX Lunch Bytes series. For those of you that may not be familiar with Lunch Bytes, this is a series designed to briefly explore capabilities within NX that are often overlooked or maybe you don't know very much about. Future sessions will be delivered once a month, usually the second Thursday of each month, 12:30 Eastern, 11:30 Central. Please check our website for upcoming Lunch Bytes topics and dates. We also want our Lunch Bytes to be valuable to you, so please let us hear your suggestions on future topics that we should cover and send those to us in an email. Also, for today's session, if you have any questions regarding today's session, please write them down and send them in an email. We have a few of you on the line with us today, therefore you'll be in listen-only mode. If you have speakerphones, we don't want interference coming across. Last month, we started a discussion on synchronous modeling, which we called NX Synchronous Modeling Part 1. Today, we will continue with Part 2 of NX Synchronous Modeling. So, as far as our agenda goes, this is a slide I use for Part 1. What is synchronous modeling? We discussed that in the Lunch Bytes, the Part 1 Lunch Bytes. I'll do a little bit of review here in a minute just to quickly go over that again if you are new to this session. Also, what are the synchronous modeling tools? We covered about half of those in Part 1, and we'll continue the other half today in Part 2. And we'll talk a little bit about history and history-free mode. Keep referring to NX Synchronous Modeling Part 1. There is a replay of that session on our website at www.allyplm.com. Just go underneath Lunch Bytes and look for NX Lunch Bytes, and you should see the replays there on the screen. So just for your reference, if you are watching Part 2 and you didn't get a chance to check out Part 1, this will be a continuation of Part 1. So just a little bit of review, like I said, kind of give you an idea if you haven't watched Part 1, what we're talking about. Where can we use these synchronous modeling tools? Well, there's kind of three areas to look at it. One, on imported solids, obviously we don't have a history of how that solid was designed or made inside of that native CAD system. So this would be like importing a step file, for example. So using these synchronous tools on that dumb solid, I know that's kind of the generic term that we use for these dumb solids, meaning we don't have the history, the native history. This would be one environment where we could use the synchronous modeling tools. The next environment would be on NX native part files, but we also have a history-free mode inside of NX for our native geometry. It's kind of behaves the same as working on that step file. We're just not tracking the features inside of history tree. We're directly working with model faces and doing what is also known as direct modeling. The third would be once again on NX native parts, but with history. Okay, so you can use synchronous modeling tools on top or alongside other history-based commands. So those are kind of the three environments that you can use synchronous modeling in. So like I said, this is one of the common ideas. I've imported this step file or this parasolid or something from another CAD system into my NX environment, and I have this body or this dumb body. I don't have the history of how that was modeled in its native CAD system. So how do I make changes? So that's the big power of where these synchronous modeling tools come into play. Excuse me. So like I said, in Part 1, we discussed, or Part 1 of our Lunch Bytes last month, we discussed the modify face, drop down, move face, pull face, offset region, resize face, and replace face. We also looked at delete face. We also looked at the detail feature group, which includes resize blend, reorder blends, resize chamfer, and label chamfer. And we also looked at the reuse group, like copy, cut, paste, mirror, and pattern faces. So today in Part 2, we're going to continue on with the rest of the tools. We're going to look at the face relate tools. We're going to look at different shell tools so we can create a wall thickness inside of these history-free models. And also we want to look at some 3D dimensions. I want to drive the distance between one face to another face to be a certain value. We can use those tools for that. There's also a group face icon we'll look at, and an edit cross-section tool we'll look at. Finally, there's an optimize group, so we'll look at how to optimize a face and replace a blend, kind of to simplify some of those B-spline shapes from our imported body. So first of all, let's start off with face relate. So we're going to look at tools like make coplanar, make coaxial, make tangent, and so forth. You see the list there. What we're doing here is we're basically building design intent directly to those model faces. And the way the command works, for example, in the screenshot, you see make coplanar. You have a motion face and a stationary face. And what you're going to say is, I want to take face A and make it coplanar to face B, which would be the stationary face. So face A would move to stationary face B, which based on coplanar, or whatever tool we have selected here. The motion group is what faces are going to move. And as we talked about in part one, lunch Bytes, you see that we can maintain design intent and bring other faces along for the ride based on coplanar and some of these other conditions. Also in part one, we talked about the overflow behavior and how these faces calculate as they move and interact with adjacent faces. So that option still applies here because we are moving a face. All right, let's take a look at some of those tools. All right, here I have a blank part. I'm just going to import a parasolid file. And right now I am working in history-free mode. Just in a minute, we're going to switch over to history-free and do a little bit of comparison for you. But here I have that body, right? How do I make changes to this body? So like I said, we looked at the move face tools in part one. We looked at resize blend, resize chamfer, those tools, delete face, and we also looked at the reuse tools like cut, copy, paste, mirror, and pattern. So now we're going to continue on with the rest of the synchronous modeling toolbar today. So I'm going to come in here and let's just use make coplanar as an example. And notice I have my motion face and my stationary face. And the way this works, maybe I want this face to be coplanar with this face. Notice how it moves to be in a coplanar condition. All right, same thing with this side face. Maybe I want this face to be coplanar with this face. Once again, see how it moves to create that design intent or that coplanar condition. If I come over here and grab this face and make it coplanar to this face, notice how face finder can come into play, and maybe I want to grab other coplanar faces and have those come along for the ride at the same time and go ahead and accept that. So I could have done one face to another face and picked up all other coplanar faces and have them come along for the ride. So that's make coplanar. These tools are very easy to use. Next one would be make coaxial. Maybe I want to make this whole coaxial with that boss, right? Just kind of seed to target. Motion face to stationary face. Here, maybe I may want to make the boss coaxial to the hole, right? So you get the idea there. The next one in the list is make tangent. Maybe I want to make a face tangent to another face. Once again, I'm just doing motion face to stationary face. The next one on the list is make symmetric. So here I have these two holes. Right now I don't quite have a symmetric condition. So I'm going to grab my motion face. I'm going to grab the hole on the right. It's asking me what plane do I want that to be symmetric about. I'm going to grab my plane. Then I'm going to say what face is that going to be symmetric to about that reference plane, and that's my stationary face. Notice here in my face finder I have coaxial turned on, and see how it actually moved the boss as well. If I turn off coaxial, it would just move the hole. So with the face finder, it grabs all the faces I want based on that design intent and achieves that move and that condition. The next one, make parallel. Like I said, these are very easy to use. Maybe I want this face to be parallel to that face. So we just created that condition. Maybe we want to make another face perpendicular or make it normal to. So I grab this face, make it normal to the base. See how now that face is vertical. All right, I'm going to come back to make fixed here just in a minute. Notice how it's ghosted out, and also show related face is ghosted out. Let's go ahead and grab make offset. And I have this face down here on this pocket. I'm going to grab this face, make it relative to that stationary face, and because it's an offset, it's truly giving me an offset value, which I can adjust or type in an exact value. So I'm going to go ahead and type in 3/4 of an inch for that. So now you see that that face is offset. Once again, by default here, I built these synchronous tools in a history-based system. So you see we had the body, and then it's tracked each of those synchronous modeling tools in our history mode. Okay? So let's talk a little bit about history versus history-free. So as I mentioned earlier, synchronous modeling tools can be used both in history and history-free modes. What you're going to notice if you switch from history mode to history-free mode, the history tree will be removed. It's going to quit calculating and keep tracking those features. Okay. The way to think of this, when we change to history-free mode, the focus is going to be to the body, right? We're going to directly work on the faces of the body when making these changes or using these synchronous tools. What I like to do is I think of making these synchronous changes kind of as the model as it sits right now, meaning, this face sitting here right now is not tracking the history. So if I come in here and do a move face or a coplanar face, it's doing it to the model as it sits at this state right now. The model does not roll back, right, because we're in history free, and features are no longer tracked in a timestamp or a history. Okay, and I'll show you a couple ways of how to transfer to history free mode. So those other tools were ghosted out because those tools are only available in history-free mode. Okay, the first one was make fixed, and what that's going to do is ground a face or a set of faces relative to the origin, so to speak, and then it cannot be moved unless that's turned off. So it's preventing those faces from having a move face or a coplanar face operation applied to them. And what you're going to notice here in my screenshots is we used the make fix tool, and if I come in here and want to move this face, it's not going to let me. See how it has a saved relationship marked as fixed, and it's actually going to say, hey, that cannot be done. All right, and I can turn that off on the fly underneath that saved relationship if I really do need to make that change. Also, if we're not sure why a face, we get this result, hey, it can't do that, that's where the show related face tool is very, very helpful. I come in and grab the face in question, and it's going to pop up this relations dialog and says, hey, those faces are with a fixed synchronous tool. That's why it's not moving, but also you see I can delete all those relations to that face and give me that degree of freedom back, so to speak. All right, so let's take a look at some of those tools. All right, so right now, like I said, we're in history mode. I can come over here at the top node in Part Navigator. I can right click and change it to history free, or you see I've turned on the tools inside of my synchronous toolbar. Right now it's on history mode. If I change it to history free, it's basically going to say, hey, we're going to strip the history out of that. So now we're looking at the model. Our focus is on the entire model. Okay? So if I look at those other tools we skipped over, I come in here now, you see how make fixed is available. So if I grab make fixed, I'm going to grab that bottom face. I'm going to use my little selection tool to grab everything inside that pocket. Now you see that those faces are now fixed. So what that's going to do for me, if I come in and try to do a move face on one of those faces that are fixed and hit OK, it's going to yell at me. It's going to say, hey, that change failed. Well, if I look over here, I see that I have that saved relationship. So I can glance over here and see, well, if I truly need to move that face, I could turn off this saved relationship. The other thing I can do, if I just cancel out of there and leave it fixed, if I look at the other tool, which is show related face, I can come in here and I say, hey, why is that face not moving? I come down here and grab that face, and it's going to show me that, hey, that's part of a fixed relationship, so to speak. That's why it's not moving, or if I do need to move it, I can right click and say delete that relationship on the fly. So now if I come in here and do a move face on that particular face, you see it's going to allow me to move it. Okay, so there's some very powerful tools. Like I said, the make fixed and show related face are history free tools only. Excuse me. The next thing I want to talk about are dimensions. So we have a linear dimension, angular dimension, and radial dimension, and these are 3D driving dimensions, meaning they're going to be to the model faces. Okay. Now, as you work down through this dialog, basically you're going to say, what's my origin, which is my start reference, what's going to be my end reference. Whatever is selected for my end reference is going to default, whatever that face, adjacent face is going to add to my faces to move. And I'll show you how that works in a minute. We have dimension, plane, and orientation options because we are creating 3D dimensions, but if you think about it, it needs a 2D plane to measure that particular distance, in this case for linear dimension. Okay, and I'll show you how to change that on the fly here in a minute. Like I said, faces to move, by default it's going to be on the measurement side, but I can add other faces to move relative to that dimension. Also, if there's any design intent, coplanar faces, coaxial faces, I can grab those and have those come along for the ride. And then dimension value, that is truly the distance of the dimension. So I change that value, that is the distance on the dimension. And once again, how the face calculates as it moves is the overflow behavior. And notice I have a locked dimension, which is in history-free mode, and I'll talk about what that means here in a minute. All right, so as far as placing this dimension, you see that I've picked the center of this boss on the left, or the hole on the left, I should say, and come over here and did my second click to this hole on the right, and it starts to preview my dimension. By default in this case, notice how it's doing a vertical dimension off of those faces, and you have a little triad that pops up. Notice how this triad, the orange plane, so to speak, is showing me that it has a vertical orientation. If I want that dimension to lie down and be horizontal, I can just grab a different plane in there, and notice how it flips the orientation. Like I said, as a mentionable item there's a lock option, and like I said, for history free, notice on the left, we did not lock the dimension, it's unchecked. Right here, I'm right-clicking on the dimension, it's showing that lock dimension is not checked, and also you're going to get some color feedback with lock dimensions. Notice how this color is this black color. On the right, if I turn on lock dimension, notice I right-click on the dimension once it's created. It is on, saying it's locked. And also notice how you get a blue color showing that that dimension is locked. Okay, so just a little bit of feedback whether or not the dimension's locked. And I'll show you what that gives us just in a minute. All right, so let's look at the dimension tools. First of all, I'm going to come in here and grab linear dimension. I'm going to go from the edge of the hole to the edge of the hole. Notice on my second click, which is the measurement item, it's going to place that face to the face to move here in a second. Okay. Now right now, notice how it's previewing a vertical orientation. If I want that dimension to lay down and be horizontal, I can just click the XY plane on that little triad, and notice how it lays down. I click to place then. Once I've clicked to place, like I said, whatever the measurement side is, it added that adjacent face to the faces to move. So you'll see right now that as I come across here, I can move that, drag that handle, and you see how it's just moving the hole, right? That's the face to move. I could add other faces to move relative to that, or obviously I can use face finder. So if I want to turn on the coaxial condition, you see how it'll also grab that outside boss as well. Okay. The other thing, remember I built symmetry between those earlier. So if I want to turn on the symmetric face finder rule, you see as I drag that, it's going to pick up that those faces are symmetric to each other and maintain symmetry for me. And, you know, more importantly, now I can say from here to here, that dimension has to be, in this case, 6 inches. Right now, I have the dimension unlocked. We're going to come back later and talk about how these are or what you get when you lock a dimension. If I double click on the dimension, I can come back in there and make changes to it. So that's the easy way to edit. The next one, we looked at linear. Now we're going to look at angular. So I'm going to come in here and just grab this edge, click to place. Now I have angular dimension. Notice how I'm moving that, or basically rotating that face based on the angular dimension. Very easy to use. I can type in a specific value. And the third dimension is radial dimension. So if I come in here and grab this cylindrical face of this boss, and I start to pull on that dimension, or I could drive a value, which I will here in a minute. Notice also you have options for whether you want to drive based on radius or diameter. Here I want to move the other side as well, so I'm going to come up and either grab equal radius or symmetry would have worked for me as well. And as I drag that, like I said, I can type in a new value and truly dimension that cylindrical face. Okay, so let's talk a little bit about lock dimensions. So if I come back to the linear dimension, I'm going to come over here and I'm just going to dimension from edge to edge, kind of the height of this pad. Let's go ahead and grab that again. Linear dimension here to here. There we go. Now right now I am going to leave it locked, or I'm sorry, unlocked. It's unchecked. So notice the feedback. The dimension's black. So if I come in here and grab a move face, maybe I just select the face, that base face, and I start to move it up. See how it engulfs or starts to climb beside that corner pad or that corner extrusion. Okay? So if I cancel that out and I just come up here and right click on the dimension and say it's locked, notice how it shows me the feedback that it's now blue in color. So if I come back to the move face and grab that top face and start to pull that up, see how it's maintaining the height of that face between those two edges. It has to maintain 1.5 inches because I locked it down. Basically it's saying no outside influences other than changing the dimension can change the height or change the value of that dimension. Okay, so we'll just back out of there. So that's locked versus unlocked dimensions. We looked at linear, angular, and radial. All right, the next group of tools we want to look at are the shell tools. You may be familiar with the shell command inside of history mode, and you may be wondering why we have a set of shell tools here in synchronous modeling. These tools are available for history free, and for history free only. So first of all, if we do a shell body, just like it sounds, it's going to shell the entire body. We do have an optional option to exclude faces. Okay. We have a shell face, which allows us to shell a set of adjacent closed faces. You can use that to include faces into an already shell body. Remember, we're not keeping track of the history. That's why that's important. And finally, there is a change shell thickness. Allows you to change the thickness value. And that's important because, remember, this is not being tracked. It's history free. So this tool allows us to go in and change the wall thickness of this part because we are in history free mode, and change that to a new wall thickness. I'll show you how that works just in a minute. Going back a step, underneath shell body, there is that option to exclude faces. So what it's going to do by default is going to shell the entire part. Well, maybe we don't want to include this little box, this rectangular shape on the side. We don't want that to be shelled, right? By default, shell body is going to shell the entire part, but I want to say except for these faces. So I can come in and exclude those faces, and then down the bottom right, you see how it does not open that and it does not shell those particular faces. And like I said, to change shell thickness, that's important because we are in history free mode. Notice when I grab one of the faces of that offset wall thickness, it actually picks up all the different offsets that belong to that shell item, and then I can change to a new thickness, and all those faces will offset to the new thickness. So let's go ahead and take a look at that. I'm going to switch parts. All right, so here, this is a part, just a little simple part that I created in native NX. I actually built it in history mode. Okay, the first thing you're going to notice are my shell options are ghosted out. Like I said, those are only available in history free mode. If I come over here to, and I want to do a shell inside of history mode, I would use my shell command that you may be familiar with already. Okay, so I want to change this to history free mode. Now you see that those tools are available. So if I come in and say I want to shell a body, I'm going to pick the faces I want to pierce, and notice how it's shelling the entire body. So if I hit OK, we are done with that item. Now it's not going to track that. Remember, we're history free. Okay, let me hit undo one time. Let's look at how, maybe we want to shell the body, but except for this block or this cube on the side. So once again, maybe I want to pierce those faces that open up. Right now, it is shelling those faces, but I can come over here and say, I want to exclude some faces from taking part in the shell, and I'm going to grab those adjacent faces. Now, obviously, I can use some selection tools to grab those a little easier, but I wanted to point out that I needed to grab the enclosed area or the enclosed volume, and notice how it removed those from being offset or removed those from being in the shell. So if I hit OK, we did not shell that cube. Now moving forward, remember, we're not tracking this. This is history free. What if I decide at a later point I do need to shell that cube? So that's where shell face can come into play. So if I go to shell face, and I want to pick up that entire cube just as I selected it before, right? Notice how it's opening up that face, right? Because it needs to be pierced. And then I can come in here and add, maybe we'll just make it the same value, 0.1. And once again, because none of that's being tracked in the history, because we are working history free, I can come in here and I say I want to change the thickness. Notice how it picks up all those offsets with the same thickness. So instead of 0.1, maybe I need to make that 0.25 and see how we've changed the shell thickness. Okay. You may have also remembered in part 1, I started off with this part, and maybe we imported it this way. I need to shell out, what looks like little handles. Well, the same type of approach, right? I'm going to do a shell face. I am working history free, so I'm going to grab all those faces to offset, also do the same thing on the other side, and then say I want to open up or pierce that top face and shell it to 2 millimeters. Okay, so it's the faces you're going to offset underneath shell face. All right, a few other tools. First of all, group face. It's going to allow, just like it sounds, it's going to allow you to group faces based on, maybe feature function. I want these 4 mounting holes to be grouped together so I can select them together. They're always going to move together. Or maybe I want this hole in this boss, like you see down on the screen, to always move together, even independent of what design intent or face finder finds for you. I'll show you an example of that in a minute, and also another tool called Edit Cross-Section. Okay, we're dealing directly with faces, but what Edit Cross-Section allows you to do is create kind of a section view down through your model, and then we can drive that section view and the model will update it. It puts us in the sketcher mode. Okay, and I'll show you what that looks like. All right, I'm going to come over here and hide these dimensions for a minute. And what we want to look at first is the group face. So I'm going to come over here and grab group face. I'm going to grab the outside cylinder and the inside cylindrical hole. Say I want those to be grouped together. So notice if I select group face, see how those will always highlight together. So if I come up here and I need to move those faces, if I come up and grab that center hole, if I don't turn on face finder, which would pick up coaxial, you see how it's able to move that hole separately. All right, so if I cancel out of there, I come back to move face and I actually grab the whole group face. See how it picks all those faces that belong to the group as my select set, so I can move them regardless of what is found inside of face finder. If I need to move the other side, obviously I could turn on symmetry, and you see how we're moving both sides like you would expect. Okay, so group face, groups faces, based on design intent, or basically a large select set as well for a move command. The other one, like I said, is the edit section, the cross-section edit. So I'm going to come in here. Maybe we'll start, and it's going to feel like you're creating a sketch, right? I just picked that front face, and what it did is it actually projected lines from where those model edges are. So notice if I drag those lines around, how my model updates. Okay. Now right now I'm just kind of free form moving those around, but notice it put me in sketcher mode. So if I come in here and I want to apply some sketch constraints, right? Connect some lines. I can place some sketch dimensions on here, and I can actually drive those. And then notice when I finish sketch, obviously I'm out of that edit mode, and the model keeps those changes. Remember, we're working history free, so that's not being tracked anywhere. Maybe I want to create a cross-section edit down the center. I'm going to come in and grab a bisector plane just down the center of the part, and I'm going to come back to edit section again. And there, notice the section view across there. Once again, if I start moving these line items around, you'll see how my geometry adjusts relative to that. Right? If I change the height and I want to come in here and place a collinear constraint between those, you see that I can go ahead and do so based on sketcher and sketch constraints. Okay, so notice it takes the shape. So it's just another way to help us, one, edit unparametric models, meaning that step file, etc., and be able to make those changes easily. Got one more kind of little tiny section here to go over, and these are some optimized tools. So optimize face helps us simplify B-spline geometry basically to analytical geometry, meaning there might be a face based on a B-spline, and we want that to be lines and arcs, or smooth, or mainly so we can edit it uniformly. Okay. One option you're going to see I emphasized, and the option is actually called emphasize faces and edges. When you turn that on, it's going to help you pick out some of that B-spline geometry in which you want to optimize. Okay, and there's a tolerance value, so we can go out and try to find different sizes of faces to optimize, and I'll show you that in a minute. The other tool that kind of works alongside of that is replace blend. Right? Maybe I have what looks like a blend, but it is maybe a non-uniform radius, or it is a B-spline like we mentioned before, and I want to come in here and find those faces and basically have it inherit the radius and transform that into analytical geometry so I can actually edit the cylinder. So I'll show you what I mean by that. All right, I'm just going to go ahead and import another model here, start a new part file, and we'll come in and let's just grab a step file. Now, one thing I did to show you how these tools work in Synchronous, I did turn off the simplify option and the optimize option here on import. There are some tools just for your knowledge that would help with that. I'm going to go ahead and go out and grab my step file. Excuse me. We'll bring. All right, so the tools we're going to look at is optimize face and replace blend over here. Now, what I'm going to do with optimize face could be done with replace blend, and what I'm going to do with replace blend could be done with optimize face. So I'm kind of comparing apples to apples for you. But keep in mind, this optimized face could be other faces other than kind of a cylindrical shape. So first of all, before I even run that tool, on part one we looked at resize blend. So I'm going to come in here and try to resize that blend. You'll notice they're not highlighted, and it's not truly picking those up as blended faces. All right, so, and if you look, you know, obviously I have some kind of B-spline shape there. So if I come up here to optimize face, I like to turn on this option, emphasize faces and edges. You'll see how it highlights the faces in question, okay? So I'm going to up my tolerance a little bit so I can modify these faces. I'm going to leave the two on the right for the replace blend, but I'm going to grab these two faces here to optimize those. I had reports turned on, and what it's going to do is show you how the model changed. So here in question maybe a cylinder. Before I had 0 cylinders, and after I had 2, right? So now these are truly cylindrical faces. To kind of back that up, you'll notice here circle. Before it was 0, now it's 4. So I have a circle here, a circle here, a circle here, and a circle here as far as the edges go. Okay? So now, because I've optimized those two faces, I can come up to the resize blend and see how those will now select, and I can make a change to those using my synchronous modeling tools. Very similar on the right, if I come over here to replace blend, I can emphasize faces again. Notice the two faces highlight. You know, maybe they don't have the same radii, you know, as it goes across that blend, or maybe it's B-spline, like I said. Now, one thing you're going to notice is the shape match. So it's going to try to inherit the radius based on the face shape or size. If I can change this, this is kind of a tolerance. And what you're going to notice whenever you go to type is, you know, you might have trouble finding that, okay? And so, but what we're going to look at, I'm just going to put the tolerance here in the center and say, I want to grab those two faces, hit OK. So now those have truly been replaced with blend faces, so to speak. So if I come up here to my resize blend tool now, I can grab each of those faces, and notice it was 0.21. That was the radius I inherited from that face. Now if I need to change it to 0.25, I can with my resize blend tool. Okay, so those tools were the optimize face and the replace blend to kind of help us simplify some B-spline shapes. All right, that wraps us up for today. I was about 5 minutes over. I apologize for that. As always, replays of our Ally PLM lunch bites can be seen on our website at www.allyplm.com. Once again, check out part 1 if you missed part 1 of synchronous modeling. Also, I think I mentioned this last time, down in the bottom corner, if you have an Android phone, we do have an Android app. You can go to the marketplace and search for Ally PLM. What the app does is it takes us to our website, and it also takes us to all our lunch bites videos for both NX and Solid Edge, kind of based on category on the phone, and it plays them through YouTube. Also, if I was being educated on this, the little bar scanner in the corner, if you guys even recognize that, you probably know more than I do, but there's a barcode scanner for your phone, and you can take a kind of almost like a picture using that app, and it'll take you right to that location inside of the marketplace. So, but like I said, you can search Ally PLM inside the marketplace if you do have an Android phone. Thanks for your time. There's my contact information. Just as a mentionable item, upcoming training offerings for NX. We have our Essentials for NX Designers. It's a 5-day class for new users. You see the dates there in July, August, October. If you need more information, you know, please let us know or go to our website, allyplm.com. There's our technical support information. Once again, thanks for your time today. Thanks for your attention as well. I hope you found this session informative. Also, please email us your suggestions for future lunch bite topics. Email us any questions you may have had during this session. We appreciate your time, and let us know if you have any questions. Thanks, and have a great afternoon.